All right, this is the notes for section 10.9, radian measures. If you haven't done so already, make sure you pause the video at this time and read section 10.9 before continuing on. So first of all, let's describe what a radian is. When we talk about radian, it's the measure that is created so that the arc measure and the arc length are the same number. So arc measure and arc length would be the exact same value. When we're working in degrees, that is not the case. Those two things are completely different. But in radians, those two things are exactly the same. And the way that we're doing that is with this definition of what radians are. The definition of a radian is the measure of an angle, arc, or rotation such that pi radians is 180 degrees. Okay? In general, the measure of an angle, arc, or rotation in radians equals the length of its arc on a unit circle. Okay? So everything is based off of the fact that the unit circle has a radius of 1. Therefore, the circumference of that unit circle is 2 pi r, or 2 times pi times 1, which is equal to 2 pi. Therefore, we can say 360 degrees is equal to 2 pi. Okay? The measure of the whole circle would be 2 pi, or 360 degrees. Okay? So if we use that idea, let's see if you can do quiz yourself number 1. It says, what is the length of a 60-degree arc on a unit circle? Well, 60 degrees is 1/6 of the circle. So that's like saying 1/6 times 2 pi, which is equal to pi over 3. Therefore, 60 degrees is pi over 3 in terms of its arc length and its radian measure. Okay, so let's look at how we can convert from degrees to radians or from radians to degrees. If I know that pi radians is equal to 180 degrees, if I want to convert radians to degrees, I just need to multiply by 180 over pi. Okay? So whatever I'm converting to, that number is going to be on top. So I'm converting to degrees, so 180 degrees is on top and pi is on bottom. If I'm converting degrees to radians, now I'm converting to radians, so notice how I have pi radians on top and 180 degrees on bottom. Okay? So usually in this book, we generally omit radians as a abbreviation with the measure. So for purposes of this book, if we give you a value with no degree symbol, we're going to make the assumption that the measure of that angle, arc, or rotation is in radians. Okay? So just in general, if you just have a number but no degree sign with it, and we're talking about the measure of an angle or an arc or rotation, we're talking about that being in radians. If it has a degree symbol, obviously, then it would be in degrees. All right, before you continue on with this video, you might want to just pause it for a little bit, reread example number 1 on page 713 in your book, because this next example kind of deals with the information from that example. All right, let's take a look at example 1 here then. So what we want to do in this one, we want to convert 1 degree to radians. Well, if I'm going to convert 2 radians, I'm going to multiply by pi over 180. And I'm going to multiply it by 1, the number of degrees that I have. So the degrees are going to cancel out, and I'm just going to have pi over 180 is what 1. So this is an exact value, pi over 180. And most of the time when we're working with radians, we want exact values. Now, if we want to get an approximation to that, we can come to our calculator. And if we look at it on our calculator, pi divided by 180 is going to be about 0.017. So that would be the value that we can use for an approximation. So we could say which is approximately 0.017 radians. Okay? In example 2 here, we're going to convert 60 degrees to exact radian value. And once again, we're looking for an exact radian value. So I'm going to take 60 degrees. I'm going to multiply it by pi over 180 because I'm converting to radians. I want pi on top. Okay, which is 60 pi over 180. And then if I simplify that, that simplifies down to pi over 3. Therefore, this is the exact value for that in terms of radians. Example 3, we want to convert radians to degrees. So I'm going to take the number of radians that I have, which is 5, 6 pi. I can also write that as 5 pi over 6, which sometimes it's just easier to keep it as a fraction like that. And then I'm going to multiply that by, since I'm converting to degrees, I want to have 180 on top, and I want to have pi on bottom. Now, the nice thing about this is that the pi's are going to cancel each other out. So I'm left with, and I also have a 6 and a 180. Well, 6 evenly goes into 180 30 times. So this is 1 and this is 30. And then if I multiply that out, 5 times 30, I get 150 degrees. Therefore, this would be the exact degree measure that we'd be looking for. Okay, if you want to take a minute or two now to see if you can do the guided example here right next to these 3 problems. Try it out, and then in class we'll talk about that if you have any questions. Alright, the examples that we were working on above kind of lead us to working with the unit circle, in that anywhere along our unit circle, for any degree measure, we can have a radian measure. And the ones that we're most interested in are the ones that are multiples of 30 and 45. Therefore, those would be the exact values of sine and cosine that we can find. So this unit circle here kind of lays that out. And the easiest way to kind of remember it is, if you can remember that 30 degrees is pi over 6, or at least be able to find that, and if 45 degrees is pi over 4, we can derive all the other ones from those two. So for instance, if I know 30 degrees is pi over 6, well, 60 degrees is twice as much. So that's like 2 pi over 6, which is equal to pi over 3. 90 degrees is like 3 pi over 6, or pi over 2. 120 degrees is like 4 times 30, so that's like 4 pi over 6, or 2 pi over 3. 150 is 5 pi over 6, 5 times 30. And 180 is 6 pi over 6, which is just pi. So for it, and we could keep going around the circle, but for any value that is a multiple of 30 degrees, if I know 30 is pi over 6, I can just ask myself, well, how many times does 30 divide into that number? And I will have I will be able to convert that to radians very easily. Okay? Same thing applies with 45. So if 45 degrees is pi over 4, well, then if I look at 135 degrees, okay, well, that's 3 times 45, so I'm going to have 3 pi over 4. Okay? If I look at 315 degrees, that's 7 times 45, therefore it would be 7 pi over 4. Okay? So the better you know your unit circle, the easier it's going to be to work with things in both degrees and radians, especially when we're dealing with exact values. And then finally, so we looked at our exact values as they relate to that unit circle. Finally, let's look at how we can use our calculator with radians, because we can find the sine, cosine, and tangent of radian measures as well as degree measures. The only thing we have to do is we have to make sure that our calculator is set into radian mode. Now the only time we need it set in radian mode is if I'm taking a trigonometric function of something that's in a measure that's in radians. Okay, other than that, we want to leave that mode in degrees. So just kind of be careful with that. If you're going to use it in radian mode, switch it to radian mode, and then I would probably switch it back as soon as you're done so that you have it in degree mode for most of what you're dealing with. So let's take a look at solving each of these. If I want to find the cosine of 6, let's look at doing that on our calculator here. So first of all, we want to make sure our calculator is set up correctly. So go to Home, and then go to Settings, the number 5, right at the bottom there, and then make sure you go to General and switch that to radians. Then hit OK on that. Okay. So now my calculator is set in radian mode. So if I want to find the cosine of 6, I'm going to put that in and put 6 in parentheses. And if I hit Enter on that, I get an exact value, which is just the cosine of 6. But if I hit Control Enter, I will get the value for the cosine of 6, which is to the nearest thousandths would be 0.960. So this would be 0.960. Okay? And then part B, it says evaluate the tangent of 7 pi over 6. Well, if I look at 7 pi over 6, from an exact value standpoint, we can do that fairly easily. I know that it makes a 45-degree angle with the x-axis, and I know that the tangent of theta is equal to sine over cosine. And I know that the sine of theta in the fourth quadrant is negative, so that would be negative square root of 2 over 2. And I know the cosine in the fourth quadrant, my x value would be positive, so that would be a positive square root of 2 over 2. Therefore, my answer would be negative 1. Okay? Now we can also look at that on our calculator as well. You'll notice if I take the tangent of 7 pi over 4, I get negative 1 using the calculator as well.